So I would like to share with you some of our experience on leading a research group and balancing in different ways. And we really did build up the group together. So my presentation is based on discussion I had with my colleague Maarja, Robotics, with whom we started building up the group without really intention to build up the group. We were just doing our own research 15 years ago, and now we are here. So I didn't really intend to lead the group. I just wanted to do my little research, and I suddenly ended up in leading. So, just a little bit about the group. Josef Stefan Institute is the main national research institute in Slovenia. We have almost 1,000 people in different fields. It's natural science, so physics, chemistry, electronics, computer science. We, as Artificial Intelligence Department Laboratory, we do have also strong connections with spin-off companies, which we contributed in establishing. We have good connections with academic partners, as well as business partners, clients, collaborators. Our research traditionally is connected to developing prototypes. So it's data analytics, machine learning, big data analysis. We heard yesterday about that. So these are what I'm showing here. The URLs are actually publicly available prototypes or demos of our systems, and several of them inspired also business clients to go and, starting from a scientific prototype, build up something which is really useful for them. And our group also has a long tradition on collaborating on European projects. So you can see listed names of some of them. We were also coordinating. I will tell you a little bit more about that later. So for the outline of the talk. After introduction, I would like to talk about some of the main points that we found important when leading a research group. And of course, many of them apply also for leadership in general, also in businesses, but I will be focusing on research here and academia. Right? So, aligned philosophy and aligned leadership approach, because there are more senior people, of course, and we want to work together. We want to maintain the flow of knowledge, the flow of our social network, collaborators, and of course the flow of funding. Then a little bit about internal organization. We find it really important to be flexible. Human resources, we all know, are crucial. Strategic partnerships as well. And then something about leadership challenges and a few words how I see future of leadership. And the small dot here is myself last summer climbing. So this is how I feel also in this leadership of research group towards success. Okay, so let me just share with you something which is actually one of the prototypes I mentioned that we are developing. This one is about monitoring global media. So what we are doing, we are crawling all the time for now more than a year, about 70,000 news sources, taking news from RSS feeds, about 300,000 to 4 every day. And as you see now, this is online. So this is happening now. These are the news as they appear, and you can see location where they are. And you can see, it's really what is showing here is not news, it's event, which we obtained by grouping the news together based on some heuristics, machine learning, guessing that they are talking about the same event. And here you can see like, 17 articles, 12 articles, 29,000 about the same thing. So why I'm saying this? Because I said, okay, so I'm going to speak about leadership and computer science. If I am starting that, as I did 15 years ago, and I want to see what are people saying on news about that, what can I find? And searching for that, I mean, you can search for other things like academic awards or something, but I just did the search on leadership in computer science. So we can do it here. leadership. Computer science. These are what the list is, different name entities and terms that we automatically registered that appeared in the corpus which is behind this search. So these are events connecting like 6 articles, 14 and so on, and it's cross-lingual by the way. And I can sort them, I just sorted them according to what is hot in social media. And this is the most hot thing, Microsoft of course occurring on the topic of leadership in computer science. And there are some other events, women fallback in tech industry and so on. So you can read about that as well. And what the system allows is also different views on that. So what are the entities occurring in these events? What are the keywords? What are the top publishers talking about that? So in this case of our search is Business Journal, USA Today. We do clustering of events. So what are these 60 events about? We can look at that. It's a lot about women, and then they cluster about women, and here it's North Korea, country, management, and so on. So you can browse through this in different ways. Look at a single article or single event and look through the articles which are in there, what they talk about, how they occurred over time, what are the related articles, and so on. So based on this, and I would encourage you just to try yourself the website and play with some other things which maybe are more present in news today than what I was showing. But basically, what I wanted to show you, in addition to showing you a great demo that we are proud of, and it's also a nice collaboration also with Bloomberg Company in USA, with New York Times. I wanted to show you that if I want to learn about leadership in computer science, academia, research from the news, I'm not going to learn much, at least I didn't. So after finishing my PhD, I started very soon coordinating a European project. And also, by the way, Artificial Intelligence Research Institute in Vienna was one of the partners on the project. So it was a great experience, but it really took a lot of energy, a lot of efforts, and to be honest, didn't really inspire for future leading of coordination of European projects. It was, especially for someone fresh in the leadership, it was very difficult. I mean, my weekends were basically working, sometimes also in state other partners, because as coordinator you have to cover for everything, right? So I figured out, I'll just share with you some of these lessons that we learned jointly through that coordination of European projects, which I took from the slides I wrote at the time, and I think the lessons are still valid. So one is, of course, success doesn't depend only that I have good partners on the project collaborating with me, that the content is really good and we are good researchers. It's really also about flexibility of partners and the project reviewers, because on the way you need to change things. It's not, you start with the description of the project, which ends up being whatever it needs to be, not exactly what you planned a year or two ago. And I'm sure many of you know that, because you have experience with that. The other thing I learned the hard way was what does it mean to have that someone is a good partner. And basically, the issues we had was mainly with business partners, which were really sticking with what was written in the proposal because it was legally binding. And when we needed something else that wasn't in the project description, they were like, we are not paid for that, but you needed to do it. So you really need a partner who shares the vision. And we'll see later, it's not just for the project, of course, for any collaboration, you really want to share the vision. For your family life, you want to share the vision with your partner. And also small things really matter. So you need some team building. We had social events here every evening, right? So we know it's important. But at the time, I wasn't aware how important that was. And also a strong team. And the project should be our joint adventure. So this is a photo from the time when we had the project meeting, and the project was called SoluNet, Solomon European Network. It was about data mining and decision support on different use cases, on working on real data. Another little story which came from there, because that was a research and development project, is differences everywhere, which was for me at the time surprising, but not just for me, also for some a bit senior colleagues. So one big issue was research versus commercial. Basic motivation is different, which in a way it's natural, but it can cause problems in collaboration. Also, there is difference in personal motivation, why people are doing something, and difference what are the workload priorities. For instance, business partners were really surprised when we said, well, summer is a conference season and we are not going to do the same amount and dynamics of work as we did before. I mentioned already flexibility as very important, and also really to have at least a few project partners which are core, which are going to keep the vision alive, which are going to push things further even when the times are a little bit shaky. Okay, so that the last two slides were the previous experience. Then I went recently to look at some definition of leadership, and of course I went to Wikipedia to read what does it say. What is leadership? Let me share with you. So one thing, in leadership in US academic environment has been described as a process of social influence in which a person can enlist the aid and support of others in the accomplishment of a common task. And I took another definition from different background, which says leadership is the art to induce an empowerment to bring to realization the project or mission based on a vision, where we are reaching the goal involving, stimulating, elevating other people through your projection, caliber, example, leadership, and command. And on a hard level, if I want to look at that a little bit of, what is the main message? The first one says, for me at least, I am engaging others to support me to reach the goal. The second one says, we are reaching the goal together, involving, elevating, supporting others. Needless to say, I prefer the second one. And then, going after that, I was thinking about leadership in science, and basically, my conclusion was, everyone is a kind of leader. In scientific work, you had first to lead yourself. Nobody asks you, but you do your individual work, you work on your PhD, so there is some leadership of yourself. You have to plan the example, the experiments or whatever, you have to find the literature, you have to write about your work, present. You have advisor, but still, there is also a good portion of leading yourself. Already as students, we collaborate, so there is someone leading, maybe we are switching roles, but again, there is some amount of leadership. And then, of course, there is explicit leadership. And the photo up there is showing three of us, which are basically leading two groups, two departments. One is Artificial Intelligence Laboratory, and the other one is the group which has, this is a colleague, videolectures.net portal. Maybe some of you are familiar with. We have this about over 15,000 different lectures available, a lot from computer science. So the explicit leadership, there is some work which is organized in research environments. We are all leaders in some way in this structure. And there is also work which we do as in our academic career, which is leading students, advising students. Then we also collaborate with our peers, and somebody is leading. And then there is also a work on the research projects where there is predefined leadership, but it's just for the scope of the project. When the project is over, then maybe you find yourself in another role. So I'm sharing here also a quotation which I like, which is reflecting what I just said. Let me share with you. In order to be able to lead others, a leader must be authentic and experienced in leading himself by combining both intuition and intelligence. So not simple. If we go back now, after these personal reflections, to leading a group. The first thing I mentioned is a common philosophical fundamentals, or simply said, just no nonsense. So what does it mean? The common vision we want to have, which we are all following and contributing to, and here are the examples for our group. A long-term vision, which is we do artificial intelligence, we work on text understanding, global observing analysis of global social dynamics, sensor data analysis. Then we have also midterm goals, vision, which we share, which is working on research projects on multimodal data analytics. So it's a bit more specific, and the projects, there are more projects which contribute to each other. And the short-term vision, we have a specific project, specific research problem that we are solving. In a group, we also need a high level of enthusiasm. And then in computer science, what we found important is also no religion on tools, algorithms that you are going to use. So, I don't stick with using specific programming language, specific method if it's not really suitable for the problem I'm solving. Also, no nonsense in research, meaning that whatever we do in research, we put some time, we put some resources, energy, it should at the end bring some kind of profit. Whatever is profit, you have research paper as a profit, you have new projects, new systems developed, new algorithms, whatever. And also no corruption in research. So really to stick with being honest about ownership of ideas, how the approach was developed, what are the results, how do you report, how you collaborate, write papers, how you get funding. So basically you want to maintain in a group vision and enthusiasm, which I found as the most important. And 10 years ago we were active on promoting women in science and interviewing different women, asking how do you build up your career, how do you feel science? And here is what I said at the time, that as I feel being a scientist is more a way of life than really an occupation. And I still think that's valid, at least for me. A bit more uncommon approach to leadership. If you have a group and more people leading, you want to be aligned in a way on how are you leading, what are you doing. So one of the important things for success of a group, I think, is really to look at enhancing your assets through the projects, which means you don't get research projects, research collaboration just to cover the salary, to keep you just alive. You want to create something, you want to have more. At the end of the project, you must have more. And you want to reach this more with also involving people who are growing, who are improving in their knowledge, in their understanding, consciousness, happiness, richness. So you want to have more, and you want to have really people who have more at the end. So everyone should be satisfied at the end. You keep going until this win-win situation is achieved. And on the way, you show some gratitude, you show some kindness, you tell people they did well, you share what is good, what is not good. But really important thing, which we too often forget, is to give awards, to tell people they did good. We just had some discussion recently, especially on management. If you do well, nobody notices because everything is running smoothly. But if you make a mistake, then everyone is on you. So it's really nice and important. We are all human. We like to be acknowledged for our good work because this is giving us a motivation to keep on. So also with students, if someone is doing well, you want to tell them they are doing well, so they keep doing that. They can differentiate between when you say nothing and you praise them. So another thing for a group to really grow and be successful is to maintain the flow, which is, one thing is flow of knowledge and experience. You really don't want to stick with things, and you can't in computer science, especially not. You want to also keep the flow of social networks of partners, so you want to collaborate, share. send students for internship, teach, have research project, have people visit you, visit others, and so on. And of course you need a flow of funding, because you want to create an environment in which you can really do your research and your teaching and your advising. So we see today that really information is accessible everywhere to everyone. The challenge is really how do we consciously choose the right information and how we verify this, what we think is right information, through our experience. And one of the struggles and why we do this, all this big data analytics and analytics, is really to get out of the information some knowledge, something which is valuable for us. But when doing so, we really want to have balance. As in general in life, we want to balance. We hear a lot about work-life balance, but also in research. So for a group to be stable, it's good to kind of spread a little bit your activities, which means, and which we also do actually in our group, is we work on applications, which is applying our research results on concrete problems for industry, for clients. And this is fast in changing, things, the demand changes quickly. Then you want to do applied research, which also is solving problems, but not immediately. It's like prototypes that we do. And then you want to do basic research, which is interdisciplinary. This is giving you stability. And actually, this is one of the things which really helped us to build up the group. About 2004, I think, European Commission, which was before funding machine learning research development of algorithms, wasn't interested in, they decided that it's already developed. So only application of that with collaboration with another discipline is going to be funded. And this is how we started working in semantic technologies, because we kind of combine our machine learning algorithms, extending them, changing them for the purpose of semantic technologies. On the other hand, we also would like to be specialized for some things, which is then giving you possibility, to go in depth with the topics. So in our case, it's covering data analytics, text and social network analysis. And you also want to do application not all over, because there are many interesting areas where you can apply your research, but you have to choose. So we do it in, as I showed you, media monitoring and also modeling complex data. Then for organizational structure, you really want to be flexible. Preferably in academia and research, we have almost flat structure. So the hierarchy you have, in addition to whatever is necessary on the organizational level, is something which emerges by itself. People who have more to share, who have more experience, by inertia or by the effect of that, become leaders of some little group or of some collaboration. Then we also need well-defined roles. So we are flexible, but on the other hand, you need to understand what are the roles and define them. So who is responsible for what? Otherwise, it's not going to work. And of course, allow for new roles to emerge as the situation changes. In our case, these new roles emerging were connected to growing, so we needed a special person for financial management. Before, it was me doing that when we had 3-4 projects, but when you have 15 projects, no way you can do it. And you want the internal organization to be as fluid as possible. So the role really depends on context. In some project, one person can be leading a task or sub-project and the other person working on that. And in the other project, there is the opposite situation, which I think is really healthy. It's really good that we experience different roles. So then when you are in another role, maybe then somebody else is leading, you can understand what they need from you, because you have your own experience. How is it when you email and there are deadlines and you have to chase people to provide? So the organization in any way should be such flexible so it's facilitating personal and group progress. In identifying the needed roles, there are some roles which we know about, they are predefined. They just are based on theory practice. You know, you need some secretary support, you need system administrator maybe, in addition to doing your research and teaching. And then when you identify the roles, you also need to figure out what is needed for that role. I don't know, secretary needs some office space, telephone, computer, whatever conditions people need, so you can really expect from them to work effectively. And the other one is, as new roles emerge on the way, how you deal with that, how you recognize them, and are you able to get people who are going to cover that roles? And in addition to identifying roles for which you need different people, you also have more roles on yourself. Like I was thinking, what are different roles that I'm playing today? And there are many, like one is working with students, this is from a PhD defense. The other one being in discussions, reporting on research, and also having some time for fun. So for the organization, when I was reflecting with a colleague, Maarja, on how really this group that we have now today of 40 plus people grew, it was very organically growing. So at the beginning there was a core group, like 2-3 of us, and they really collaborated already from our undergrad studies with computer science national competition for high schools and university. So there was this connection with top students in the country, which is really important, and I can tell you that many members of our team today actually are from those top students, very enthusiastic and interested for the work. So on the top of this core group, we slowly gathered core researchers, and of course then we needed more of the support. First you need secretary, that's at least for us, and then we started working on dissemination channels, and that's where this videolectures.net portal started. And I would encourage you, this is a URL, if you type this in, you will find the portal. I would encourage you to check. It's really a very, very nice resource of material. And many colleagues are using that when teaching, especially in graduate studies, giving students, a homework to watch through some of the lectures, because there are world-leading researchers talking about their own research. There are summer schools recorded, hours and hours. So after that, you need some support researchers, and as I mentioned before, a person in charge of finances for the group. We do have accounting system at the organizational level, but this is for the group. When somebody comes and says, okay, I need to buy this piece of equipment, I want to buy something, on which project do we charge it? Because it's more general than for a specific project. So I don't want to be the person, which I used to be, answering these kind of questions all the time. And project logistics, this is a role which we made up recently, 2 years ago, just figuring out there are many calls for project proposals which are just not under our radar because it's too much. But there are good chances for collaboration in them. There are good topics that we can explore inside those possibilities of funding. So now we have a person who is not just monitoring the calls, she's also helping in writing the proposals, doing all the things which we all know you repeat so many times, description of institution, your own CV, whatever, many things which you don't need a scientist to work on. You do it once and then it's there. And then another thing, which is really one of our strong points, I would say, is to have what colleagues from US are calling commercial arm of your group, which is these spin-offs which I mentioned, with whom we collaborate really well. And another thing which naturally emerged is a kind of advisory board. So we have several people from around the world with whom we collaborate very well, and gradually through time they become as a kind of advisors for our group, like good collaborators, some of them part-time employed with us, really helping us. Human resources, of course, crucial for any collaboration. The first thing we have is really know-like, which is important for collaboration and kind of respect between the people who are in, high trust between the people who are in the group, which you manifest or you grow in different ways. One is really transparency in communication and no gossip. Sometimes you can notice that somebody wants to, blame someone else for something. You stop it immediately. I mean, that's not the point. I don't care what bad things some person did. Tell me what good things they do and how can we collaborate on that. Which is also connected to early conflict detection and conflict resolution. Of course, we are all human. We get into conflicts. What do you do with that? As a leader, it's your responsibility. You have to work on this. On the other hand, as researchers, it's really important to, be honest, to do your work honestly, so there is no bluffing. And in our group, it's really strong. It doesn't matter who you are. If it looks that somebody is, trying to pretend they are something they are not, it's not going to be quietness in the group, which I think is really healthy. And we also openly share knowledge, experience, of course, and there is some common understanding of what is the game we are playing in that story. So good human relationships. We have tight collaboration inside the group, also sharing some free time. Of course, that's spontaneous, whatever people want. But what spontaneously kind of now every Friday, 5 p.m. they go for a beer in a nearby bar. So we go. I don't go so often, to be honest, but I'd rather go home and spend time with my son. But I think it's really nice to do it. Also, to support each other. So there is no really competition inside, beyond what is healthy kind of competition, helping each other to grow. And on the long run, we really look on individual growth, individual priorities. So we have a project and maybe somebody works on the project, they are not very happy with the content, they would like to do something else. But you say, okay, we have to finish this, keep up, but thank you for letting me know that you would like to do this other topic, so as soon as there is possibility, or we'll try to apply for different kinds of topics and so on. So in the long run, it's really to keep people growing and doing good research. You also want to, in connection to human resources, you want to promote talents, you want to figure out what is the talent of a person and help them grow in that. Of course, with the students, we all need to cover a minimum, right? The minimum skills of doing individual research, writing, presenting. But there are also some specific capabilities that individuals have, and you want to support them going in depth in this way, right? And it's theory, is it seeing a new opportunity for collaboration, whatever it is. So I was reading a little bit and thinking about how really science itself depends on individuals. And really science, to be excellent, relies on excellence of people who are doing it, right? So you want people who have vision, who have ideas, who have a goal which is bigger than themselves, so they are going to move, to make changes, to move the limits of what is possible. And have courage to do that, have enthusiasm to go through that, to fight whatever it means on different levels, to fight with the problem, to fight for the funding, to fight, for space, for collaboration, that have persistency, grit, that they stick with the goal and go for it, that they are open-minded, they have humility, which I often see, especially with young students, as a problem, When you are young, you may think, your solution is the best, you are the smartest, you want to do it your way. Well, what can you do? You can just suggest and let people try themselves. People, of course, who have knowledge on the subject they are doing, knowledge about related work, who trust in the vision, and they have a kind of healthy openness for risk, taking a risk, People who have grace when facing difficulties. So you don't lose time and energy fighting, you just see what is the best solution in this difficult situation and go with that. And also people who are determined, who have strong decision and go for winning, not losing. So when you start doing something, you go with the idea you are going to win, right? You're not going to start doing something saying, oh, it's not going to work. As a group, we also need, now when talking what we do in the sense of collaboration with others, we need strong reputation and trust, which we want to build. So for having that, you want to maintain high standards. On short term, you want to perform well, good on a single task, single, deliverable, whatever, single collaboration. On mid-term, you really want to contribute to success of projects. And on the long term, you want to have good technology developed, you want to have alliance beyond a single project, you want to build complex solutions which can then be, continued, upgraded in future projects. So let me share a quote. In the context of business, your job tests your trust, as it is impossible to convince other people to trust that you are good in your business if you don't trust yourself that you are good, right? So you really have to have situation clear with yourself. You want to build strategic relationships, partnership. You want to have operational links. As a research group, you want to have links with academia and with businesses and also with government. And here I'm just giving a few examples of the collaborations we have built up through years and we found very, very interesting. One of the things, when I say with government, funding agency, one of the things is our methods for text analysis and social network analysis were noticed by European Commission as, kind of, oh, this is what you are doing in the project, so maybe you can do it for us. So we ended up doing analysis of a network of organizations, who is collaborating with whom on a project, on which topics and so on, which was fun. An interesting application for us, in fact, but also very useful for the funding body to see what is happening. So leadership in science, it's a little bit different than in general, I think. 5 minutes. Good. So it should support excellence, everyone growing professionally and personally in consciousness and gaining experience. You also should not attach in the sense that, you want to get some research results and you expect something from your experiments, but we heard yesterday, also negative results are valid and good to share if you learn something out of them. You need to be flexible. You need to see opportunity in every situation to learn from experience. Be authentic, know for yourself first what are your strengths and what are your weaknesses, and go with them. And something about challenges for a leader. So maybe, so one thing I mentioned is maintain a common vision over time, high quality standards, and do not get lost. Do not, just be lost in your vision. See that you keep with the original intention. You also want to delegate work. This is one thing which I kind of learned not so recently, more maybe a year or two ago, when I become very frustrated. So let me share with you, just keep this around, if you can check, which is something that they came across looking for what can help me in facing different kind of challenges. So for delegating work, I guess all of you noticed, if something can be done by somebody else, not you, they should do it, right? Because there are some things, many things, that can't be done by anyone else than you who hold leadership position. So if you keep too many roles on yourself, you are just wasting time. And you are just partially utilizing your own talents. And for leading the whole group towards success and maintaining success, you really want to develop a strategy. You want to have this common vision and then work on it, develop observe, think in advance, what are the consequences of becoming successful, managing to get to this common vision. What is going to be then? How are you going to be suddenly have multiple tasks, multiple roles, multiple responsibilities? Are you prepared to go for that? Because if you are not, then there is no point in trying to achieve the vision. You also need to understand in advance what are the needed resources and energy to understand if you want to go this direction or maybe you want to do it differently. And also consider possible problems, so you kind of develop a plan B and see how can you, for instance, survive if there are reduced funding opportunities. So if you want to be a successful leader, you should really make sure the whole group is successful, right? So people are happy and prosperous. This is the way how to consider success. And this is almost the last slide, which is just a few thoughts on future leaders. I think the leaders in the future really should be experienced first in leading themselves. Be clear enough to understand the situation around them, what is happening, how are the people perceiving, how people feel, how is work going on. And they really need to act consciously, not just, get into fights or get into, being too upset. So they need to lead themselves. And they need to have self-respect, because if you expect that other people are going to respect you, which you really need if you are leading, no way they can do that if you really don't show self-respect towards yourself. Also, they need to have a discipline to hold their vision alive, their intention alive, and work on that. Notice opportunities and use the challenges to really make more out of that. Flexibility, I talked a lot about that because I really think it's important on all levels, mental, physical, spiritual. Which means for the leader, you really need to have capacity to hold. You know how it is. People knocking on your door with problems, throwing them on you. You are there to kind of take a deep breath and see what to do with that. You can't just throw that back to them, right? That's why they come to you. So basically, you must also have a kind of code of conduct, in the sense of you don't blame others, you don't complain, you don't compare, you don't gossip, you don't lose energy on these kind of things. And you need to be able to recognize talents of other people and support them in growing. And this is my last slide, which is just to show you our group website and the address, and I would encourage you to check. And this is our group a year ago. On one of the retreats, actually, which I really find really important, we do it yearly or bi-yearly, that we go for a few days to a remote site and discuss about the strategy, about research, management vision, and of course we are having some fun, doing some bowling, whatever. We have people who are playing instruments, so we had the evening of music, playing, singing, and so on. I think I'm on time, huh?
Thank you very much, Linda, and thank you very much, Hans, for inviting me here. When Hans first asked me to come and talk about how to organize my work in future, I quite frankly then it was quite annoying to me, because I thought it's way too open-ended problem to think about. Until I finally sat down and started thinking about, so how do I really organize my work? And so I did a little bit of soul-searching and reflected back from what I've done so far and what I'm doing in the future. And I ended up actually with few questions I'm now trying to answer during the next 45 minutes here. And first, I would like to give a relatively broad perspective to make us realize what is a global trend and has to be very strategy going in the future. Because if we're talking about organisms already in the future, so it's better to understand where the future is going. And also to be proactive in a way, how do we proactively already encourage to answer to developments in these trends. And finally, I take it down to personal experiences, how I personally try to cope with these changes ahead of us. As maybe it wasn't so evident from the introduction from Linda, I'm actually trained as a computer engineer / computer scientist. So I am one way in mathematics in engineering. But when I got my first PhD student who was a professional software developer, he told me, Maarja, you know, for the sake of world peace, it would be good don't write a single line of code. So I didn't, and I was a bit crazy now. And I started, I actually delegated also code writing, and there was some PhD students, and started several research groups into the and started supervising some research and doing research. So back to thinking about, talking about future. Here is a forecast by McKinsey about the future key technologies up to 2020. And also some possible market shares of those technologies then. And if you look at the slide here now, you could realize that about first 6 of them, the biggest trend makers in the future, are actually in information and communication technologies. I'm using this stupid term ICT, which is, I know, sounds very bureaucratic, but it's a little wider than informatics. And I do it mostly because I'm also an engineer, and I do that as a broader view of IT, also comprising engineering. Now, if you look at those science and engineering perspectives, then you see that 6 of the first technologies actually is ICT. And the rest of those, more or less, in smaller or bigger amounts, also incorporate a lot of the ICT research in them. A big chunk of this work is associated with the growing amounts of data. There's another forecast, actually all the forecasts in Google Studio are like geometric trend or something. More or less all look like this. But here you can see that the way data is coming and we have to deal with data is growing incredibly fast. So one of the big problems is how to store data, how to protect data, how to acquire data, manage data, analyze data. And all the 6 first trends from McKinsey actually ask the same question. You don't have good tools to do this, and we're probably impeding in the technology development. But then again, if you're asking now questions that where all this data, this big data comes from, then it's quite evident if you look at another forecast of how Internet of Things is going to develop in the nearest future. And a lot of this data is coming from devices, from embedded sensors. For example, one of equally geometric trend is a wearable sensors. And here you can see that big data has eyes and ears. They collect data from the real world. This is now data that is sensor data that needs to be pre-processed first before it ends up on the disk of a data analyst. So big data is everywhere. It's in traffic. It's the sensors and traffic monitors. Also, there is smart houses, smart cities. You name it. This is just one of the possible ways of collecting it from wearable sensors. But then, besides big data having eyes and ears, it appears it also has hands and legs. In this context, robotics is nothing more than a mobile data collection machine. And probably in the future it also adds a greater amount of data to all zillions of terabytes of data that we are facing ourselves. Robotics is in a place where interesting trends happen in the market. If you look at a view of robotics about 10 years ago, said a robot was an industrial robot. It was probably something machines that worked in a car factory and welded cars. Whereas somewhere 2010, a breakthrough happened, robots started moving out of the factory floors and into other types of applications, but mostly people started selling consumer robots. So instead of being closed behind the factory floors, the robots started to appear among us, in our homes, for example. And also robotic toys and the scene, so it's not so weird anymore since the robots around. But the forecast space, and so far the forecast has been more or less true, except of the recession that happened in 2008 and slower the development of the market a little bit. But otherwise, it's the growth in this technology is not coming from industrialization. We already have automated the factories very well, so there's a little margin of that. But there's this growth is mostly coming from these consumer and service robots. Consumer robot is something that is a consumable. You go to the supermarket to buy one, like, I don't know, a cleaning robot or something. And this is a service robot which is, helps people or professionals to do certain jobs. For example, you can speak about, here's just one example of the agricultural robot. This is a fruit picking robot. And it's actually two, besides the nice mechanics, it's actually a big data collection machine. And most of this kind of a robot is actually software development. About 80% of the 80 of developing a robot is actually developing the software for the robot. This kind of robot needs to, first of all, realize where it is, where it's going, to make a plan, recognize where is the fruit, and sometimes the mechanical bodies that fix the fruit. This is also controlled by the control engineers. So there's a lot of IT, actually, which is invisible, but it's everywhere in this robot lab. Another kind of a trend, or another kind of an example of either service robot or a consumable is a drone. They suddenly appear from somewhere and not flying around, everybody can buy one for a boy for Christmas, or you can buy one for a holiday party. So there are both service robots and consumer robots. And the trend again says that this kind of robots is a very rapidly growing market. Now, so where does it suddenly appear, how to deal with it, is another story, because I'm getting back to that, because people are kind of unaware that this kind of technology around, and they don't know how to relate to it. Here is a understanding of what is a robot by a PPP private-public partnership in Europe, or EU Robotics. And if you look at how well do you see the text here, but if you look at the electronics in the gray box, the rest of it, you could more or less associate with informatics, computer engineering, data analysis, and things like that. So a very big part of the robot, as I said already, is concerned with development of software. Traditionally, robotics is a discipline that stands on three legs. First, you have mechanical parts of robots, where you good mechanical engineers to develop the machine. Then you need control engineer, because you need somebody who controls the machines. But on the top side, you need computer science and computer engineering, because somebody has to program those machines, and somebody has to analyze all the data, and etc., etc., etc. Besides, the decision artificial intelligence, possibility to that sort of here. Now, when robotic research is concerned, you can try to even have one more circle around it. We're pretty much inside, we've so far been pretty much inside of a close interdisciplinarity here. We even talk about interdisciplinarity because we're rather talking about specialities within one discipline, which is IT. Those people are, you can argue, are totally different cultures between mechanical engineering and software engineering, civil engineering. So you still find kind of common ground. But if you look where the research in robotics is growing now, then we are going to have much more, so to speak, far interdisciplinarity in robotics. We talk a lot about cognition. We speak to cognitive scientists, we speak to psychologists, because we want to understand how people communicate with robots. If you talk about computer-human interaction, this is also yesterday, because now we talk about robot-human interaction. And it's really very hard to design a robot that human finds to be pleasant, and no engineering to use it. But there are also kind of far this interdisciplinarity minus biology. I work with a lot with biologists building robots. And also material science, for example, which is hard to discipline, but it's about now building totally different kinds of bodies of robots. But actually, you can hear even draw one more circle, and it says else kind of refers to something other, something you could say less significant, right? Because there are also other matters are in the other circle here. But then, again, for example, we have this demographic situation where we have one elderly people around Europe. You know, we think that very good answer. The way to deal with this demographic situation is to build domestic robots to take care of elderly people. And the robot science projects, so research projects that we go to use that. But then again, there is a reason to study by Eurobarometers that says that about 5% of people want the robot to take care of the planet, not speaking of the children. So we must have something very, very wrong somewhere. Because we engineers think this is a great solution, and somebody says that all the else things matter, and we would like to have it. Now this engineer thinks that he has such a wonderful tool, is in a little uncomfortable situation. He has to speak to social scientists, and so a lot of legal issues, for example, coming back to drones. So can you find your drone in my backyard and things like that. I was involved in two surgical robotics European projects, where the biggest problem was actually not that we didn't have robots to operate people, but the problem is that we didn't have legislation. We had about 10 years legal lag, that just can't, because of legislation, use the robots to operate. So these are all the ill things that a kind of engineer feels himself a little bit uncomfortable with, so to speak. But now, again, if you look at the trends in how we do in our research in the future, it kind of seems to suggest that we are more and more frequently faced with this sort of uncomfortable situation, working with far away different kind of disciplines. From here you could see it's actually a number of citations, number of references to other disciplines, and an interesting fact here is that people less seem to refer to work within their discipline and different specialities. For example, a control engineer would reference less the work of a computer scientist, but there is more sort of references cross disciplines, far away disciplines from their own. So this kind of a research is growing all the time. And now the question that actually comes from there is that how do you, if taking the interdisciplinarity is a mega trend, everything is going to be interdisciplinary, multidisciplinary, we are there in the future. So how do you maintain the balance between disciplinarity and interdisciplinarity? So make basic criticism against interdisciplinarity is that you don't have interdisciplinarity without discipline. So you need to have some discipline. But also for ICT, especially because it's such a broad field, is how do you balance your speciality and sometimes interdisciplinarity around. I'm going back one more time to the same slide from the beginning of Mackenzie, which actually says the role of the mega trends we are anticipating in the future are slowly about ICT or heavily involved in ICT. And it looks like ICT is present everywhere in whatever we're doing. And I think it's sometimes thought that it will lead to this kind of a very strange paradox called the value paradox, or called the diamonds and border paradox. Diamonds and border paradox because if you ask people what is more valuable, water or diamonds, and the people will say, well, of course, diamonds. But then again, you can very well think about diamonds, but you can't think of water. And at the same time, we do appreciate it. Well, see, a reason here is that there is sort of a threat that ICT is going to be treated as water, something which is everywhere. Like, in our car, in our buildings, in our watch, in our computer, in our chair, whatever, the things in the internet, but it's kind of invisible, it's taken for granted, everybody knows it is there. And also the ICT people feel those things. So there's a little, I think there is a little bit of threat that we're just going to treat them as an anonymous army of plumbers. It's good to have some, build up things, but then again, we're not very careful about it. And it's a little risky in a way, because with all this growing data, amounts of data that actually do lead new theories of the levels. How to analyze the data, for example, like probability test emerged as a response to the growing amounts of data. So probably new theories to come. But then again, it has its army of plumbers, so probably not too well positioned to develop such very new theories. And we've been talking about this vertical and horizontal skills and everything. Quite people do now refer to that, and yesterday there was also some reference to T-shaped people. Actually, there was a T-shaped competence came from two researchers in Harvard Business Review, and if you look at the original context of a T-shaped group of people, so these people were concerned about how in a big company you have, in an organization you have departments, units, how have deep expertise, but at the same time a global view of, what the company generally is doing. And it became sort of kind of a way to develop managers. And as it always happens in academia, we talked about 10 years later, and we thought that was actually a very good idea to manage a project as a company already in private companies, very good private. But so the T-shaped person would say, look something like that. He has a deep knowledge and expertise in a certain area of expertise, and then your horizontal integration, either with other disciplines, for example, you have a deep expertise in robotics, but then you also know quite a bit about arts, and so you think you're well positioned to do robotic arts. But you didn't claim yourself to be an artist at the same time, not to somebody else you're working with. But So you need to work, so to speak, your way in far disciplines to me. You also need focus on innovation and creative thinking capabilities, thinking out of box from your own discipline and accepting that other people think differently. I would even put on the horizontal bar of the team a sense of empathy. I think this is needed when you work with very far away discipline. This is else issues. You need to understand the wider context where your research and development stands leading. The problem with this T-shaped analogy as a person is that it's very sensitive to your own way of interpreting things, right? I just bounced it back from a friend of mine, his first comment, you think you're like that, and everybody else thinks you're like this. And this is probably true. It's very much up to the interpretation. But I think still that it's a very clear sort of a tool or a thought experiment to try to understand where the team goes. And you could do it only not just for yourself, but for example, your research group, or your company, or your university, or whatever. When it comes to interdisciplinarity then, or multidisciplinarity when we come on a system level, since the way allegedly is best to do inter or multidisciplinary research. Interdisciplinarity only refers to concepts within one person, and multidisciplinarity is more on the system level, with people or organizations with different disciplines and putting together. And the idea here is quite obvious actually. You have teams aligned with each other in arms and legs of deep expertise that you need to solve a certain problem. And then you have this horizontal ones that are dealing with this sort of people having exceptional interpersonal skills and ability to think out of the box and having global vision and things like that. How much is this really achievable is of course a good question, and here is my sort of a case study into how this should happen. 2007, I started a new little research center in Mladenic University of Technology called the Center for Biorobotics, and the name already says that this is very interdisciplinary in nature because it has two legs, so to speak. It has biology and it has robotics. The biorobotics actually is a subfield, so to speak, bionics. Maybe you heard about bionics or biomimetics. So it's actually kind of a design concept, a general narrative that you study nature in order to adopt best solutions that nature has developed already, and then you apply it to solve a specific technical problem. In robotics, it could be, a different kind of robots that function with different principles, but those principles have already proven to be successful in nature. And of course, once you start a research lab, it's first, I think, if I look back to that, it's going all this sort of phases of team building, like what is this forming, storming, norming, and performing. So first, nobody knows what to do. You have quite arbitrary bunch of people with arbitrary skills, and nobody knows exactly in what direction are we going to go. And then you start consolidating your expertise a little bit together, but some things really maybe go wrong or doesn't fit into the picture. I'm not saying it's wrong, but for example, I have supervised an art student who worked in smart textiles, and it was a very nice thing to do, and she got her PhD, but it didn't need anything that fed back to my lab anymore, so I didn't throw any expertise on top of it anymore. And despite being a very nice experience, I don't think I would do it now anymore, just because in the longer perspective, being all over the place is probably not a good idea. And then after a while we had several surgical robotics projects, but then we understood this is not our field really, and we worked really, these projects were successful. I was a little disappointed because there are no research enough. We started a company, but the company work 1 month ago close to town, so I would say it wasn't actually a very good idea to go into that. But after a while I was realizing that after going through, a lot of, losing people and people going away with an expertise, financing caps and everything. So we so slowly started to realize where our expertise actually is. From the very beginning we were doing this bio-inspired robotics and underwater robotics. And actually this is a kind of field which is very labor intensive. Just building things underwater is hard. It's, electricity, water, you understand, yeah. And actually you need a lot of technical skills, which is not research. But you still need very skilled people who build those things and work reliably. And it doesn't come overnight, it comes in years. You finally have this army of engineers and young researchers who know how to do engineering underwater. And I think it could be different disciplines. For example, you decided now you're going to machine vision. As in the computer, the entry barrier is very low. You just keep starting it. Before you realize there are a lot of people who think this way, and the competition is very fierce. So in underwater robotics, it's completely different. It's very hard to go over the entry barrier. Once you say the problem of positions, you do something very reasonable with this expertise. And now we're more or less converging with you one of the three vertical pillars of our century. And of course this is a moving target. I'd like to do this sort of a team shaping exercise at least once a year with my team to everybody to understand where our expertise actually is lying. And this year, for example, we changed vertical because we also developed field-tested competence. Before we just did lab experiments, but now we can go out in the field and we know all how to run a field operation. And it's not that easy as you think. It's actually requires a lot of knowledge. Here are just a few examples of what we have done so far. Here's a turtle robot. And it's bio-inspired, so it's a bio-robot. Why it's a bio-robot? Because it resembles the turtle. Why it resembles the turtle? Because turtle has solved the problem how to move quietly and have a very high maneuverability. And we adopted this kind of idea to build a very maneuverable robot, a small robot. And actually it comes from a project where the goal was to develop technology for underwater technology. And the archaeologists told us they need a device to go inside a shipwreck, look around, take some video footage, since they're radio is an analyze. So in this project we worked together with underwater archaeologists. And our team here is clearly on this high-tech robotics. We never complained with the archaeology, but we're very happy to have teach the archaeologists to work with, the history building to work with. And as such, it's a really nice experience to work with people like this. Here you can see how it fits into a little bit bigger picture. Here is a sonar scan written by the robot. If you don't know how to read sonar scans, never mind, but there are two kind of little objects there, and you could see that there are some pieces of machinery. And one of those machines is actually on this picture here. And now we're sending another robot that goes over this machine and does video modeling. So the archaeologist has in this computer a 3D image of the object, the shipwreck of Sicilia's flying underwater. What you can do by just flying over is to have also this 3D model for the interior of this object. So instead what we did is sending in our turtle robot that goes inside, ties inside of the shipwrecks or other objects. And below here is the video footage from the onboard camera. So from the onboard camera video footage you can put it into the 3D image. So what an archaeologist has on his test later is the same object, the shipwreck, but water is taken out from this container. She can turn it around, look inside and outside and see if there's anything valuable at all that gives this reason to go and investigate it any further. Few other things that also we've done in our lab is another bio-inspired robot that works as a fish, and the reason it is propelled by a fin is because fin-propelled animals are much more efficient than propellers. Not really exactly as flat wire, this is something that we're also trying to do, very efficiently working under the robot. But what is more remarkable, so not seeing so well in these pictures, the way the robot senses the world, is that having this locomotion ability, fish have a sense for the lateral line sensing. It's a sense for sensing flow. No humans have it, but all 30,000 fish species do. So it makes you wonder why all fish has developed that sense, whereas robots don't have it. Maybe it's useful underwater. So what we did here is develop robots that can sense flow and analyze and interpret flow with it. And we showed that if you understand the flow limits, you literally swimming with information. You can become very much more efficient if you use energy from the waters, for example, you understand better where you are and so on. But what was even more interesting for me was that we fed this information back to the biologists who were working with it. And biologists used it as a tool to understand what fish sense. You can't ask the fish what do you sense in the water, but if you put this robot in this place, then you can understand, you can look at the signals and you say, okay, in this place you see this, you feel that. And one of the most rewarding moments in my entire career was I was about to be brought to the authoritative scientist and I didn't stand to the guide. Your work is very hard for sufficient and thought. And then one of the professors said, this is not true, because you made fish talk, now we understand what they're saying. And this was such a wide moment for me, because I realized that I actually did something useful for Sam, and I created something practical. Having got inspiration from biology, I also created something practical with biology so that they could understand biology. Here is another example where we take the same fish robot into a river and put it in different places in the river. And then we do signal processing. It's just a signal. And what you do with signals, you put it out lines, and then you do something more sophisticated. You could classify the signals, for example, in different clusters. And then you suddenly realize that in a river with some sort of a flow state, there are flow signals that are very distinct in different places. You literally can step in one river twice because the signal is secondary. And also we paid it back to biologists who will say, yes, this is what helps us to understand how fish navigate. How do they, for example, go upstream? We have a project now, a couple of weeks ago, we were also in Austria, and we measured fish passes. And fish passes is something which is next to a hydro-powered plant, and fish have to go this way up. So how does it know that it has to go this way, not this way? Well, most of the time it doesn't. Most of the time the fish rays are not functional or just partially functional. And what we do here is that we take a fish robot and we put it here and we put it there. And we ask, is it possible that there is a difference that makes a fish decide one or the other way? And if we could correlate it whether the fish pass function or not, big data analysis, then we could actually feed it back and see what kind of fish passes should you build in order to have fish going to their spawning ground. There is another very interdisciplinary project that we started quite recently, and this is, that's coming from my computer lab. sort of fluid dynamic experiment running. Yeah, that's not rain. Here's sort of an out-of-box thinking, because we have a fish sensing organ lateral light on massive scales. It's supposed to be tens or hundreds of kilometers wide, and we put it underwater to get data from the painting from gravitational colors on the bottom of the sea. And big data gets us out and analyze this data. We understand how oceans are functioning, how the circulations in oceans is going on. So I'm about to conclude, don't worry, Linda, there are a couple of slides left. And one of them is sort of my experiences or my lessons learned, trial and error, mostly error, how to build and run interdisciplinary research themes. Not so surprisingly, these are not so dissimilar from Julia's reflections about how to run a research group. One thing that is really very important is that all those different people who work there, archaeologists, archaeologists, or oceanographers, or somebody feels that they have common goals, they have a common problem which solves everybody cares about. If this doesn't happen, then probably it's not a good project, or you didn't really define the building in the responsible way. And another sounds kind of trivial, as if you have to search for t-shapes, but sometimes it's very hard. Sometimes you have to talk to 2 or 3 people before you write somebody who can explain to you key things very easily. And he's interested in what you're doing with his followers. And the next thing, I find it very easy to do listening on today. Some people do it, some people want to talk themselves. But I'm very happy listening when a biologist or underwater archaeologist tells me, because I think it's very interesting. I just keep asking them to talk to me, it's great. Because the next book is going to have great properties, because it requires patience, and this is what I do have. And at some point you have to accept it, that things take much more time when you're working in an interdisciplinary team. I was quite amazed how much work is working with knowledge of arts or it's a training vision. Yes, it's a training vision. You can understand what it is to do vision art for the first month. And then the training was 3 months, and then he dies. And then it's like all over again. And you're just sitting there looking at where is my day, where is my day. There's nothing to do. And the same thing, last summer we were out with the archaeologists to go to explore shipwreck. So exciting, 17th century shipwreck, to go there, it's 2 hours to go there, and the captain said, we did it back, because of safety issues, especially students. And they said, is this how you organize your work? And he says, yeah. Or do you organize a letter? And you're done. And it's very hard for me to accept, because I used to have very organized life, which is not fair, because the last years there's a lot of uncertainty in that. And it also brings to the last point that I was thinking about several times, stressing to respect the way you must people working, because, well, sometimes it can be obstinate, but sometimes there's a very good reason when you have these kind of procedures, whether you use methods, 22 religions about your method, and so on. Probably just be more open-minded and forward. But very kind to this point here, actually I have a message so that just remember what's very important. When you go back home, you educate those informal students. We still sense that data just is not there, just like that. So it's actually very complicated. I realized myself having the robotics courses and I have IT students, and they all was taught that first you have bits and bytes, and then you start doing your stuff, right? But actually, not you have bits and bytes, you have a lot of protocol for it. You have all this analog signals coming from the sensors, you all the signal processing. People do a lot of things to get this data, and it leads to very unpleasant qualification I understood that I'm not going to do what to do every team. So when I had to computer science and the myself we built a quick management, it's data and said, honestly, I don't think it's an intellectual effort, it's just that it's data. And a very respected diplomatic graduate. So I think what people here call expedition is good spacecraft, just a big data, and it's probably, you could actually be so that's probably something that we're not realizing when we're putting together this experimental science. And also the other hand, we also make the mistake now being respectful against IT devices. We kind of get our data and the topic to plan and say, we instead of going and getting some more from a very easy science experiment and being validated. So all you have to start with cultural differences. It's very good to speak about them because, then you can educate better T-shaped people. I realized on the last moment I'm not so very wrong because this is the last couple of weeks ago a number of ventures that was dedicated to interdisciplinarity. And there was a 5-word fund like mine, emphasizing more or less the same thing but more systematic. So the same message is almost there. I'm coming to the last slide of my talk, which is one of my favorite quotes ever from a great Spanish thinker who talked about T-shaped people long before Harvard Business Review did that. He did it more in a very journalistic context, and I think it's also a perfect quote to thank you very much.
So, do any of the audience have specific questions for our speakers, or want to start discussion based on that? Are you thinking of so one of the things I was looking about in your talk, when you were talking about how you were growing a group, and it sounded very much like you were building a startup company. Are there parallels with the cross-level these activities?
We used to think about doing the startup, but it was, I think, influenced by the way of thinking that we want to have something operational working at the end. So, and we were also getting people who wanted to get their research applied. And I think this is partially influenced by the fact that our research group, even when I started doing research and head of department was at the time in Bradford, was really about using machine learning on data. At that time it was medical data, medical records. So maybe from there is a parallel because we went into this building a robust research vertical group, and today it is even, we almost can't afford hiring a person who doesn't know how to program things. I mean, because then somebody else has to program your ideas. We all have more ideas than we can implement, so, who's going to implement others' ideas? Sorry.
Marie, do you have observations on startup and building research?
Yeah, in some way it's similar and some not, because the startup has a much shorter time horizon than a research group. A research group probably doesn't last forever, maybe, but say 10 years. Time horizon is okay, whereas a startup, it means that exponential growth very fast. You start growing very fast in half a year. So in this respect, I think it's very different actually, because it's good to have a startup with a very dedicated core group of people who have the same work culture already, and get it to the level where you can start growing, instead of a research group where you have this. Maybe it's good to have this diversity from the very beginning, because you have more time to reflect on things. In this sense, it's quite different.
Any questions from the audience?
This is a question for Dunja. do a lab, every evening you sit around the fire and you sing Kumbaya. So, but as we all know, human beings are angels and devils. And each one of us is our inner and something devils. And I've never seen a human organization that doesn't have to do with internal conflicts. So far it's harmony, as I said, there's a total harmony, one family, everybody is happy. Tell us the real story.
The real story is that if you work hard, and as I said, try to solve any conflict immediately, so you don't let it cook there and make a big issue out of something which raises. And of course we have conflicts, and of course we have our personal interests which may clash with others' personal interests and with the group interests. But for me it's really the common vision, because if I have a common vision for which we agree that this is important vision, then everybody is hopefully a little bit more flexible, prepared to put aside your personal ambition, or to say, look guys, it's not my common vision anymore, I'm off. And this is also okay. And just not just because of common vision, but people are different. I mean, I have students which finish with us, they like working, but they say, I'm off to Google, or I go to, I don't know, some other, go for a company, which is also fine. Not just for them, also for us. I mean, you build up nice relationship, hopefully, right? If you as a leader, I believe you should support the person in their talents. If you did that well, if you supported your student, then you have good collaboration for the future. So of course, it's not, it's not really about
I love the Moshe's little thought about in the fireplace, but I want to support you very much in what you say in terms of leadership, in the sense that I must have worked in many groups with different types of leaders. And there are leaders where it is just obvious that the whole group will follow that leader and be with that leader, no matter what, simply because of the attitude that comes down, and others where it is also part of the duty. And it is the sense of we need to do this together. And actually you can't buy that, you can't make it happen. It is just either there or not there. So you're very fortunate to be there, especially in the scientific environment.
Especially in the scientific, we are all strong individuals, I guess, in science. And great enthusiasm for our ideas, so how we put it together.
Thank you, Maarja. I really appreciate your considerations, especially the element water, rather also as a metaphor for computer science. In the risk for computer science being water in the future. So my question would be, what was your experience in your interdisciplinary projects? Was your work as computer scientists in these projects evaluated by your cooperation partners, and also is your interdisciplinary work at your university valued by the university and the management of the university? Or is it taken for granted that you as a computer scientist support the others in doing their research program?
No, I inherited computer science for granted, definitely not. Good computer scientists, even if it's good model, it's already very important to have and appreciate what it does. I consider myself a roboticist, so I actually did work with computer science from Oxford University, and I always try to get best steps of people who work on problems and has a very deep knowledge and expertise in what they're doing. I'm not going around my university actually asking, hey, computer science, anybody?
Any more questions?
So this is interesting spirit of Bush's question about conflict. And you talk very much about leading a group while looking at the group yourself. Any conflict will come from one side. Your group will be under threat because the team is the idiot, they will want to cancel your group, or somebody else is trying to steal your floor space, or all kinds of things. You didn't say much about, you talked a lot about being the leader of the group rather than being the protector of the group, in a potential hostile environment.
Yes, maybe because I feel the most helpless in these kind of situations. Like that. I mean, in our situations, it's really one choose office space. And there are, different groups fighting for the same office space, you can't do much. So I guess the best, for my group, the best is just try to not filter things, so that not all the group is frustrated as much as you are, because you can't communicate, on a higher level. And I would expect that with experience you develop skills of convincing people and, putting a word for your and putting your interest of your group in the perspective. But I think this is my big point, actually, that maybe I didn't share much of that. I think I would be able more to learn from you than to tell something about this.
Okay, then I'd like to thank the speaker for the great contribution.